Docker Compose files are written in YAML, as shown here. YAML is a simple language used to describe data and configuration. The key thing to understand about YAML is that indentation matters. It's how YAML knows what belongs to what. We use indentation to group items under a parent. All this will become clearer as we work through this example. So in our first example, we're creating a single container application running Nginx. At the top level, we have services. This is the parent section for all the containers in our application. We can think of each container as a service that contributes to the overall application. Under services, we have web. That's the name of our service. We're free to choose whatever name makes sense. Notice that it's indented under services, making it a child item. The settings beneath web describe how the container is configured. Image is the name and tag of the image that we want to use. Ports lists the network ports. The number on the left is the outside port on the Docker host, and the number on the right is the inside port on the container. In this example, Docker listens on port 8080 and forwards traffic to port 80 inside the container. Notice the hyphen or dash symbol before our ports? This is YAML list syntax. Because this is a list, we could include multiple port mappings here if we need to. This whole compose file does exactly the same thing as this single docker run command. It starts a container from an image and maps a host port to the container port. The compose file is more verbose, but it's also more powerful and reusable. So where do we put all of this? We save this into a YAML file. The default name that Docker Compose looks for is compose.yaml, so that's what I'm going to use. With our compose file saved, we can now run docker compose up. Docker automatically finds the compose file and brings the app to life. Running it like this puts us in interactive mode, which allows us to see the logs in real time. Let's stop this and run it again. This time we're going to use the D flag. This starts the application in detached mode, so it runs in the background. To check what's running, Docker Compose ls gives us a list of all active Compose applications. You can have many running at the same time. Docker ps shows us the individual containers making up the app. Each service you define in the compose file will appear here as a running container. And when we're done, Docker compose down stops and removes the containers. Let's expand on that example. This is still a single container app, but with several new configuration items. There are 3 new top-level sections: name, volume, and networks. Name is a friendly label for the entire application, handy when multiple apps are running on the same host. The volumes section defines any storage volumes the app will use. The networks section defines the networks. Under the top-level volumes section, we have web content. This is the name of the volume Docker will create for this app. It's a simple volume with no special settings, so the name is enough. Inside the container, there's also a volumes list. This connects the named volume to a path inside the container. Nginx will serve web content from this location. And because it's a list, we can attach multiple volumes to the same container if needed. The networks section at the top level defines a network named DemoNet. We've set its driver to bridge, which is Docker's standard internal network type, the same one we covered a couple of videos ago. The container has its own networks list, which simply references DemoNet by name. This is how containers are connected to the networks defined in the compose file. The last new item is container name. This gives the container a specific name when it starts, rather than letting Docker generate one automatically. It's optional, but it's very helpful when you have many containers running and you need to identify them quickly. Have a go at creating a compose file like this one and running it yourself. It's a great way to get comfortable with the format before we move on. In the last video, we saw that environment variables can be added at build time using the Docker file. But we need to be careful. Anything baked into the image at build time stays in that image, and anyone with access to the image can read it. Passing environment variables in at runtime is much safer. The values are not embedded in the image, they're only present in the running container. This means a compose file is a better place to store them, since access to the compose file is something that we can control. For production environments, you may even consider using a separate .env file alongside your compose file to store these variables. Docker Compose will pick that up automatically, and that will keep secrets out of our main compose file, making it easier to share the compose file without exposing sensitive values. Here is a two-container example. We have a Postgres database and a web-based management front end called Adminer. Both services have an environment section. This is where we pass configuration to the container at runtime. Many containerized applications support this, as is the case with both of these images. The Postgres image supports 3 environment variables that let us configure it on first start. That is the name of the default database, the username, and the password for that user. Without these, the service would start with default settings that aren't quite as useful for our application. The Adminer service manages database servers. It has an environment variable, Adminer default server, which tells it which database to connect to by default. Conveniently, we can use the service name db here. Docker Compose's internal DNS handles the rest, exactly as we saw previously with Docker networking. We're really only scratching the surface of what Docker Compose can do. But there's one more feature I want to cover: building images directly within Docker Compose. Why would you want to do this? Well, there might be a few reasons. If you're building a custom app and you want to build and deploy in a single step, if there's no pre-existing image available to pull, or if you simply don't want to push a custom image to a registry just so you can use it locally. To build an image inside Compose, we add a build section to the service. The actual build instructions still live in a separate Docker file. This just tells Compose where to find it. Docker file is the path to the Docker file. Context is the working directory. A single dot means the same directory as the Compose file. The image key sets the name and tag for the built image. When you run Docker Compose up, the image is built automatically before the service starts. However, once the image exits, Compose won't rebuild it on subsequent runs, even if you change the source files. It just reuses the cached image. If you make changes and need a fresh image, add the build flag. This forces any service with a build section to be rebuilt before starting. Services without a build section are completely unaffected. There may be times you want to restart all the containers in an app without changing anything, just a clean restart. Running Compose up again won't do it if the containers are already running. Adding the force recreate flag tells Compose to tear down every container in the app and start them fresh, even if they're healthy. It's a clean restart for the entire application. I hope you found this series useful and that you're now equipped to start working with containers in a practical way. And just as a reminder, this series is really just a taster. My full Docker and containers course covers all of this in a much greater depth. It has hands-on labs, real-world scenarios, and complete coverage of everything from beginner to advanced. If you want to take your skills to the next level, the link is in the description. I'd love to see you there.